In this lesson, we will show that 1 squared plus 2 squared plus and so on plus n squared is equal to n times n plus 1 times 2n plus 1 divided by 6. This result we can prove it using mathematical induction. If you don't know what is mathematical induction, watch our previous lesson. Here, let's check the base of induction. Base of induction is this result true for n, which is 1? Of course, 1 squared will be equal to 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6. This will be 1, and of course this will be 1 times 2 times 3 divided by 6, which is 1. Let's check it for n, which is 2. We will have 1 squared plus 2 squared is equal to, using this formula, it will be 2 plus 1 times, it will be 2 times 2 plus 1 times 2 times 2 plus 1 divided by 6. Left part will be 1 plus 4, which is 5. And the right part will be 2 times 3 times 5 divided by 6, which is 5. So the base of induction is correct, and we see that for n, which is 1 and 2, the result is correct. Next, we will show that what is called the step of induction. The step of induction is that assumes that the result, our initial result, is true or is correct for some integer number k, or in other words, 1 squared plus 2 squared plus and so on plus k squared is equal to, let's remember what is this, is equal to k times k plus 1 times 2k plus 1 divided by 6. So assume this is true. This is true. And is it true? Is it true that result is correct? Is correct for k plus 1? Or in other words, 1 squared plus 2 squared plus and so on plus k plus 1 squared is equal to k plus 1 times k plus 2 times 2k plus 1 divided by 6. So is this true? Let's call this equality an ultimate equality. If we prove this ultimate equality, we are done. Let's call it ultimate equality. So we just have to prove this our final ultimate equality. Let's do this. Let's rewrite this. 1 squared plus 2 squared plus so on k squared plus k plus 1 squared is equal. Using assumption, this is equal to this. So we rewrite it and we will have k times k plus 1 times 2k plus 1 divided by 6 plus k plus 1 squared. Next, we can write it as 6k times k plus 1 times 2k plus 1 plus 6k plus 1 squared. Next, we can take k plus 1 out and we can write it as k times 2k plus 1 plus 6k plus 1. Okay. Next, we can write it as k plus 1 times, here we will have 2k squared plus 7k plus 6 divided by 6. Next, this quadratic term 2k squared plus 7k plus 6, assume this is an equation, and discriminant of this equation will be 7 squared minus 4 times 2 times 6, or 49 minus 48, which is 1. And that's why the root of this quadratic equation will be root k1 and k2 is equal to minus 7 plus minus 1 divided by 4, or k1 is equal to minus 6 divided by 4, which is minus 3 divided by 2, minus 3 divided by 2, and k2 is minus 2. That's why, using these roots of this quadratic equation, 2k squared plus 7k plus 6 can be written as 2 times k plus 3 over 2 times k plus 2, or 2k plus 3 times k plus 2. And let's write, instead of this quadratic term, this term, and this will be equal to k plus 1 times 2k plus 3 times k plus 2. So is it our ultimate equality? Yes, it is, because we have here k plus 1, k plus 2, and 2k plus 3 divided by 6. And our ultimate equality was k plus 1 times k plus 2 times, it can be written as 2k plus 3 divided by 6. So we are done. Thank you very much for your attention.